Okay, Lady Ada, what is this?
Happy Wednesday. It's time for show and tell, your favorite thing of the week. It's me, Lady Ada. With me is Mr. Lady Ada. Got some snakes. Payphone. We're here at the Adafruit factory where we do design, manufacturing, testing, shipping, kitting, all the stuff that you love. It happens here. This factory in Manhattan. But right now, it's quiet. It's quiet because it's just Mr. Lady Ada and I, and we're going to be doing show and tell. Yay! Yep. It's late at night. Everyone else went home. And that's good.
They lock us in here until 10.
We're trapped here. We have no food. So let's call some people and we'll see what people are up to. And then maybe we'll fight to the death. Let's start off with some Adafruit peeps.
All right.
Scott.
Scott, what you got going this week?
Hello. Hey. Well, other Scott?
We have,
no, wait, there's two Scotts?
We have multiple Scotts.
No, we have a name collision here.
Glitz in the Matrix. Now we're gonna go with
Scott Shawcroft.
Scott Shawcroft first.
I think that's me.
Yeah, that's all
There
right.
might be more of those in the world as well.
I know.
But I don't think they're on this call.
Not 4.3. Shawcroft.
Yes. Whatever my Discord number is. So as some people who have used CircuitPython have experienced, you can run out of memory and that can be really frustrating. And part of the reason that happens is, one, we don't have very much memory to start with. We have like 20K kilobytes that we allocate to the Python code. And then we also have this problem where as we allocate it, we divvy it into little chunks. And sometimes the free chunks can be really small, but we need the code that you write is asking for more that's all next to each other. And so you can end up having like 6 kilobytes free, and asking for 512 bytes, but still not get those 512. It's a thing called fragmentation, and there's lots of ways of dealing with it. You may have, for those of you who've been using computers a while, you may have defragged your hard drive for a similar reason. But Dan and I were talking about this last week and had this idea of changing the way that we allocate objects on the heap to have one section where like these are all the things that we think are going to stick around a while. So we put all those next to each other. We won't have any holes, which is kind of the goal, right? We want all of the allocated stuff right next to each other and then one big free chunk. So I was playing around with that idea over the last week, and I made a video visualization of the way objects get allocated on the heap. So I thought I would share that here. So let me screen share. So all the little colored blocks are individual chunks of memory. And I'll play the video here. I'm going to actually take my headphones off so I won't be able to hear you. But C. Grover from Discord made some music to go along with this. So I thought I should let you listen to that. So I'll play it. It's like 20 seconds long. So. All right, so that's the end of the video.
That's cool.
Yay.
I could talk a lot. Sorry?
Can you put that up on our YouTube channel or something? That's cool.
Yeah, I'd be happy to. It's on my personal channel now, but I'll repost it publicly there.
Yeah.
If people want to know more about this, I could go on for a while, so I won't do that here. But I'll plug Discord instead. If you're interested in this, if you want to know more about this visualization and stuff, ping me on Discord. I'm Tan Newt. I'm happy to talk about it.
All right. Thank you so much, Scott.
No problem.
Nice.
You know, one time our Verizon was down when we were just like an apartment company. He said you have to defrag your hard drive and make sure you move your computer away from the microwave. I'm not kidding. Next time that happens, I'm going to send this a video. I'm going to be like, I'm done.
Yeah, so yeah, it'll be good. Hopefully 3x, like people will have less memory issues. That's the goal.
And we'll have bigger chips too.
And you can use it in your microwave. Okay. JP, what you got going on?
Hey, how you doing, everyone? I just finished writing a guide for my CoinOp Piecade arcade cabinet. So I built the Piecade. It's a RetroPie cabinet, little bar top one. And I have added our 4-coin programmable coin acceptor to it. And I just wanted to show a quick, I'm going to switch cameras over here so you can. Whoops, sorry about that. I'm going to show it in action in a second. The thing that I just added to the guide on Lady Ada's suggestion was that the way our coin acceptor works is that you can train it on 4 different coins and then tell it what to do when the coin acceptor itself senses those different coins. So what I have it doing right now is when it gets a quarter, it will pulse once. And then I have a feather that is receiving that pulse, and it says, okay, 1 pulse means 1 credit. And then it tells the Picade we add 1 credit. When you put a 50-cent piece in, and actually what I have is like I didn't have a 50-cent piece, but I have like a 2-franc piece or some bigger coin. So I trained that one to give 2 credits, and then you could have a silver dollar give 4 credits and so on. So I think the guide is going to be helpful for people who want to know how to use the coin acceptor to do kind of anything along with microcontroller. So let me switch cameras real quick, and I'll just show you that in action. You can see the credits on my Pac-Man game as I put in different coins, and it also rejects a couple of coins. I'm going to put in a dime and a, sorry, Canada, I'm going to put in a Canadian quarter, and it's not going to accept it. So let me just switch.
Bad Canadians.
I know. Sorry, guys. Sorry, guys. All right. So here you got to be able to see. Yes. So this is Picade. It has credits 0 right now, and I'm going to drop in Canadian quarter, and it just gets rejected and pops through the return slot. Same with a nickel. Doesn't like that. Here's a quarter. It's going to up this. Just went wah wah wah, and it says credit 1. And now here's this larger coin, 2 francs, and it just popped it up to 3 credits now, which you may or may not be able to see by the tiny little blob on there. And now we can just feed in credits all day long with quarters, and we're ready to play. And in the guide, I'll also show you how to make this snazzy case here, which I laser cut, but you could also print out the vector files that are included with the guide and cut that out of cardstock, cardboard, wood on a bandsaw, anything you want. So it's not limited to just people with a laser cutter. So that's my coin acceptor, and don't use that to make money because you probably don't actually own the ROMs that you're using.
Yep.
All right. Thanks for the ethics lesson, JP.
Thank you.
Thank you very much, everyone. See ya. Oh, and quick plug, I'm going to be doing something fun, probably involving lots of arcade buttons on my live stream tomorrow at 4 o'clock. So please tune in and watch me build something in the workshop.
Yes.
Okay.
We will be there. Okay. Next up, no, Pedro, what you got printing this week?
Hey guys, we brought some cookies.
Yay.
For everybody.
Thanks.
But we can't send them because of the video thing, but we did write a recipe and tutorial on the learning system, which might be the first baking cookie tutorial on the learning system. Yay. This is cool. So we used to make yeah.
Hold on. Okay. Sorry, go ahead, Nick.
Yeah, so a couple of weeks ago, you sent a tweet about these really awesome circuit cookies, look really tasty. And the way to do that is with a laser engraver, but it requires like a rotary tool and this giant jig that you need to put into it. Yeah, we don't have laser cutters, but we do have lots of 3D printers. So we figured, let's figure out how to do this with a 3D printer. Yeah, so Lamar thought, oh, maybe Ninja Flex, you wrap it around, staple it, and that made me think, oh, what about a sleeve that you can just put right on there? Yeah. So super simple technique to use this with the sheet metal tool inside of Fusion 360. So you're actually drawing this and then unfolding it, applying your texture to that, and then refolding it so you don't have any distortion on your texture. And then, of course, we also made some cookie cutters to go along with that.
Here's that about.
We actually used this during, I think, one of the delivery date videos a couple of years ago. I think Stephanie made a bunch of cookies for the office, and we never released the file. So we thought we would just combine those 2 projects, and both of the cutters and the editable is available on Thingiverse. And then quickly to show the detail of these.
That's some nice circuit cookies.
Oh, that's good.
Super crisp with the recipe that we have on Learn Guide, and then right next to that, adjust the focus.
Focusing.
Yeah.
That looks so good. And one without any textures looks pretty boring, but still comes out good. and the recipe, they taste like shortbread cookies, so pretty good.
Yeah, like a lot of room for icing.
Yeah.
Yes. I'm not.
Enough butter, it all tastes good.
Yes. Cool. So hopefully you guys check out the guide, and of course you want to print them. We have the file up,
and all of the CAD techniques, obviously, on a 3D Hangouts. You can check that out, and on Library Layer.
As Martha Stewart said, it's a good thing. Watch out, cooking shows.
3D printing time.
Coming after you. Okay. Next, JMK. JMK, what you got going on this week?
Oh yeah, hi. So I go to Zaniacs, which is this, I'm sure you know about it. It's like a it's kind of like I go to it sometimes. It's every Saturday. I go to it and it's really made so there's like classes, 3D printing class, Python class. I work with Alex there. So I 3D printed a bunch of these, hold on, mini small rocket ships.
Oh, cool. Those are nice.
And then you can just use the rafts that they print on as little holders for them because they just fit on.
Okay.
It's kind of like rafts aren't really made to be part of the print. They're just kind of required, but you can use the raft anyway, just like a holder, which is nice. And then also I finished the, hold on. I actually can't share my screen, but I'll just tell you about it. Okay. I finished JMK Web, which is kind of like a web management app. Like it's kind of like a thing you would run maybe not 24/7, but like you would update the stats of maybe every hour, so you can have make sure your website and all that is working correctly and see all the stats. You can also, if there's a 43404, just text that and messages you. And I also learned that there are 403 and 404 when the website errors. When the website's running correctly, the code's a 200, but you don't really know unless you go into inspect element and look more. And then also jmksearch.glitch.me. It is this is a cool Google thing you can do. If you type site and then a colon and then your website, like site:/jmkos.com, and then a space and then your search, it'll search whatever your search is on that site only. Which is nice because what this does is just a simple thing. It redirects you to Google with site:/jmkos.com and then a space and then your search. Also, if anybody's coding any web app or making a Node.js thing or any HTML script or website, or just want to have fun with HTML, I recommend visiting glitch.com. I got told about it from the people that moved into our old house. Glitch is you can edit HTML like normal and edit things and make folders. It's kind of like thimble.mozilla.org, which is Mozilla web edit HTML site maker, except it's the limit for how much you can store and how many files is a lot higher. Thimble only has 5 megabytes. And you can also, here's a neat feature. If you select a bunch of text, you can click a little raise hand emoji. And then on the home page, you can then get support from other people that can come to your site, come to your HTML and contact you and say, hey, I remixed it. Can you see my code so I can, help you fix it? So anyway, yeah, you want to check it out. It's jmksearch.glitch.me. So yeah.
Okay, cool.
Good work on your video. I added it to the JMK OS launch page.
Awesome.
Good work.
One quick thing. Today, for the tiny screen, the real-time clock module came and a micro SD module, which I have somewhere that I'm not going to look for right now. So now it's finally a watch. I could not really keep time before that.
Okay.
So now it's a watch. All right. Well, that's it.
Okay.
Yeah, come back next
Good
week.
Work. I did when it was potato o'clock. I did.
The potato o'clock was great.
Yeah.
Yeah.
Okay. Next up, we're gonna go to Dannon. Dannon with a bunch of kids.
Mia
What's going
and
on?
friends. Hey.
All right, you guys are on. Hi.
Yay.
And then there's also my dad. So what we're showing is, as you know that we got, our other one wasn't working. Plus also me and my mom made a tin can robot.
Oh, nice.
Oh, cool.
All of the robotic pieces are on the bottom of the can, but when you look at it at the top, it looks like a plain old little thing. And I'll turn it on. It only walks backwards, though.
There it goes.
That's a cute bot.
Yay.
Beep, 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 beep.
Beep, beep. Oh no!
Make robot friend.
Audrey.
And then Audrey also has something she is going to show. It's a tornado in a bottle.
Okay.
Okay. Audrey.
Go, 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 go. Yeah.
All right.
Oh, cool.
Tornado with 5.
Oh, great.
Literally be like super active.
Good
Okay.
work. And anyone can make those. There's lots of tutorials online. That's fun because you can see what a tornado is without having to go see a tornado.
All right. Well, nice work, y'all.
Okay, Mia, Audrey, have parents send an email and we'll send you both as seen on the show and tell stickers.
Say thank you.
Thank you.
Bye-bye.
Plus, this is Audrey's first time being on show. She never even knew about it until we told her about it tonight.
Good work, Audrey.
Good work, Audrey.
Come back next week.
Come by again.
All right. Next up, we're gonna go to the
Fire.
The fire something because the Google thing.
Firebrand.
The Firebrand Forge. Okay, that's my pseudonym, so that's me. Hello. So I made this prop lightsaber, which I have disassembled right now. So first of all the metal parts were part of a kit from Park Sabers, and I did the electronics and the 3D printed interior. So with the electronics, we have a Teensy and a custom interface board, and along with the program that I wrote. So the 3D printed chassis also holds two 18650 batteries. So I could show you on this lightsaber, but I think I'm going to go ahead and show you my test bench with instead.
Okay.
That also has the Bluetooth capabilities using the Adafruit Bluefruit UART friend, which is it visible?
Yeah.
Okay.
So there's also buttons on the lightsaber, but I've configured the app to perform the same functions. So there's the on, and there's like the different patterns that you can cycle through, and then there's like the prop effects kind of mode where it has the saber sounds, the impact detection, and like blaster noises, and there's also a music visualizer. Where you can change the song and switch the patterns. So now we're back to the light effects kind of stuff.
That looks great. Nice work.
Yeah, I think that's about that's about all.
It's great. I don't know if it breaks some type of ancient Jedi tradition or whatever, but there's enough room for an as seen on the show and tell sticker. If you want one, email support@adafruit.com.
Okay, and I'll go ahead and post a link for the video of it, the saber doing all that stuff in the Discord.
Oh yeah, and when you email for a sticker, just say send this link to Phil, and the team will send it to me. I'll post it up on the blog.
Okay, thank you.
Woo! All right, next up, Isaac. Hello, Isaac. I'm your mic and choose project.
Hi, I have been working on a sound-powered GIF generator. Using various APIs and P5.js JavaScript library, I've kind of taken, the idea is to be able to kind of reflect your environment, your sound environment through GIFs. So it took quite a few turns, but I'll just do a demo first so you can get an idea, and then I'll explain more of the kind of ins and outs of what I had to do. Can you see that?
Yep.
So the way it works is it's going to take a sample of anyone that visits the website. It'll ask you to use your microphone, and it'll take once I click the screen, it'll take a sample of your environment, like a 3-second sound sample, and then it'll generate some GIFs based off of that kind of sample. So in this first one, we'll say we're in a quiet, we were studying. It's a nice quiet day. And so you want to generate some GIFs based on that environment. So we'll see what happens.
All right. Here we go.
Do you want to share your screen so we can see it?
Oh, can you not see it?
No, not you. You flip to you.
Oh, I've been showing you this whole time.
We were like, we were into this.
I was into it. I'm just like, this is cool.
Oh, my bad. Let's try that again.
There's like brain waves that like make it go, but no, these are sound waves.
Okay.
Can you see my screen now?
Yeah.
Yeah, there's like some black and white stuff.
Oh, this is cool.
All right.
All right, let's try this again.
Wait, you just closed it or something.
Oh, that's weird.
Yeah, don't once you get there, don't mess with it.
Oh, okay. Let's try this again. So strange.
All right. Yeah.
Can you see that?
Okay.
Yep.
Yeah, now stay there. Okay.
You can see this?
Yeah.
All right, let's see.
Calculating.
Doing something.
There we go.
Oh, look, bird.
You're a falcon.
Right. So it's, I mean, this is supposed to be showing like nature-y, relaxing things because it calculated that.
Oh, this is nice. I'm
Oh,
feeling
yeah.
that.
That sound. So if I were to do it again and play some music, then
Yeah,
like I'll play some like royalty-free Beatles, and we'll see if it works. Or can you not see anymore?
No, we
Yeah,
can
we can
see.
still see.
He's
Oh, okay,
calculating.
cool. All right, we'll
That's
see
cool.
if this works this time. All right, so it's a little bit different.
Yeah.
So yeah, that's the idea.
Woo! All
All right,
right.
nice work.
Well, when you send
Yeah.
a note to support Adafruit for a sticker that's not animated, it's a regular sticker. Drop a note, and we'll post up a link, and we'll have folks try it out.
Sure, and I'll put the link to the code in my repository and everything, so anyone can mess around. You just got to get your own API keys.
Yeah.
But yeah,
All right. Good work, guys. That's fine.
thank you.
I'm gonna just play it here at
Thank you.
Adafruit and see what type of gifts
I
it
know.
makes. Yeah.
Machines.
Okay. Next up, if everyone can keep it to a couple minutes, we can get everyone in. Bill, welcome to the show and tell. Bill, what you
Hey,
got?
Bill.
Hey guys, how are you?
Good.
So we are very much focused on something we have in about 2 weeks, the Maker Day at ATIA. But I took time to goof off, and so I did something completely non-AT related, which is not like me. But we did when we built this building, we actually got rid of about 84 T12 LED or T12 bulbs, the old fluorescent bulbs, and we replaced them with these, which are LED T8 replacement strips. They're pretty cheap now. You can kind of get them anywhere. And I got a dead one. And so when you get a dead one, at least in my case, you take it apart and see how it works. And I learned two things that were really interesting. I thought I'd show you guys. The first, I'm going to switch my screen here for a second. The first thing I learned is that the way they do the LEDs is really kind of cool. Okay. Let me see if I can see this better. So they don't actually ever transform it down to low voltage. They actually run 24 LEDs in series, and then the next block. So they actually, if you read the text here, it says 24C by 5B. So 5 cells by 5 blocks is 120 LEDs. And by doing that, I think all the circuit does is transform it from AC to DC, right? So I just think it's a really neat way to run this, and that you don't actually have to transform it down to low voltage and then run them all in parallel. And I thought that's kind of cool. It's probably really cheap, right? And I thought you guys might get a kick out of that. Primarily Lamore, I thought you might get a kick out of that.
Yeah, this is cool.
And then, so the other thing I learned is kind of neat, which is that and I'll leave it on this screen for a second, is that the track on these happens to be exactly the right width to hold neopixels.
Yes.
And so I've been meaning to do this for a few months, but on my most busy week of the year, I decided to actually go ahead and stick a strip of neopixels in there and run the, bring it back up here and show you.
That's very nice.
Yeah, run the, hold on, there we go. So go ahead and run the fast LED demo strip here.
Cool.
And this is like the world's fastest diffused lightsaber ever, because it was a leftover LED strip. It looks fantastic. It diffuses it great. And it's actually meant to do this. And it cost me it cost me nothing because it was a dead one. But even a new one's only, I think, about 11 or 12 bucks.
Yeah.
You can take it apart and use this really, really fast. I mean, all this is, I'll turn the lights back on. All this thing is here is a little blue fruit feather, and that's it. So it's a blue fruit feather, 3 wires, took no time at all to put together, and it's a really good way to jumpstart. In this case, I'll probably use it for Lori. She's giving a presentation, and I'll have it set up so that she can use it as a pointer because she has a great big wall-sized board of pictures to point to. But I thought it was kind of cool and a really easy project.
All right, Bill.
All right, thanks, Bill.
Thank you so much. You get a show and tell sticker if you want.
Thank you. I always love them.
All right. Next up, we're going to try to get to everyone. So we're going to go to GB and then Adam and then C. Scott. If you can keep it a minute, we can get to everyone. But you got to go, go, go. Go, GB.
Hey, you can hear me, right?
Yep.
All right, wonderful. So
60 seconds, go.
With that magical box that I said I ordered, here, I'll show you what it is. I'm going to put my headset down for a second so I can get it.
Oh, here we go. Here we go, here we go.
So I said it ended with 64.
Oh, this is nice. Okay. You weren't messing around.
Commodore 64.
Cool.
So, yeah, that's all fun, but here's what I've actually been working on really for the last week or so. I've been working on the CPU again. I worked on adding more RAM modules and debugging quite a lot.
Yeah.
So now that has more RAM modules, you can actually it can actually save data now to 3 registers. But I still got a lot more to program. And yeah, that's.
Come back next week and keep showing this virtual computer.
Yeah.
And there's enough room on the C64 thing for a sticker, but you have to do something with it.
Yeah, I already have some software. I'm just waiting for the screen to come in.
All right.
Okay, cool.
That's a deal. That's a sticker deal. Okay. Adam and then C. Scott. Adam, you got a minute.
Cool. 1 minute. This will be fun. So, if you've been following me on Twitter, you've noticed that I've been dealing with a really, really, really annoying 91 megahertz noise. If you look right here on my oscilloscope, I've got this, it looks almost like a sawtooth. That's my horizontal scan pattern. And if I go ahead and zoom into that horizontal scan pattern, you can see we've got quite a bit of noise on that horizontal scan pattern. Go ahead and stop it and really punch in. And we really go in, we can see we have noise at just about exactly 91 megahertz. So we're in the FM band. I have been dealing with this all week. I dug a trench. I tried to add more ground. I tried to refactor the circuit, try and deal with this. This thing is driving me insane, and I haven't quite got it yet. Turns out I live shockingly close to a 51,000 watt FM transmitter for public radio in Washington State. So dealing with that's fun. I'm trying to counter it with a better ground, but even though I have a truly ludicrous amount of grounding now in the shop, and I'm still not able to get where I need to be and sync the signal. So I think I'm just gonna have to try and refactor. I'm in contact with the station, trying to figure out their backfeeding EMF or something. But we'll get this sorted eventually. In the meantime,
electron microscope calling.
Yeah, no, I can actually I can play the radio station and see the modulation in the noise on my scan generator, which is less than desirable.
Well, I can always wrap the garage in tinfoil, I guess. I don't know.
Yeah, I know. 51,000 watts. That's really hard to combat. But if we look right here, I'm trying to get this close, so I'll be pretty quick. This week I got to go to a friend's shop who plays with acid, and we were able to decap the sci-fi chip. So we've actually got the sci-fi right here. We're at about 16,000 times magnification, but we can pull out and see we have magic silicon structures that we're not going to have time to get into today because I need to let somebody else go. Anyway, so that'll be more on that later.
Yeah, come back next week and keep posting the photos because we retweet them and they're amazing.
Yeah, for sure. The reason I'm kind of annoyed by the noise is that it's limiting my acquisition times significantly, so I can't really get high resolution photos while I have this 91 megahertz public broadcasting noise on my SEM. So we'll figure that out eventually.
I hear they're getting rid of public broadcast stations anyway, so.
Oh, yeah, you know.
Outlast.
Yeah, we'll see.
All right, C. Scott, if you could play us out in 30 seconds or less, we can do this.
I just wanted to show you, this is after 8,000 parts. This is a complete deck screen. Uses my filters and my oscillator processing, but it sounds like this.
Sounds like
But yeah, it pretty much replaces my Blade Runner machine over here to my left. Next week, when there's more time, I'll give you some detail on the boards, what the build is like, where to get them, and if you want to pay me lots of money, I'll build one for them. But it takes 3 months.
Yeah.
It's not a machine to make. Anyway, you guys got to get going. I'll talk to you next week.
Okay. Thank you so much. You can play some music on our way out. Thank you so much. JFK, Isaac, GB, Dan, Audrey, and Mia. See Scott, Bill, and Adam. We'll see everybody next week. We'll be on Ask an Engineer in like a few seconds. Bye, everybody.
Bye, everybody.
Full house tonight. Woo.